Alright, ladies and gentlemen, this is Mr. Williams here with an introduction to Bohr's atomic model and why we use it. First off, by the end, I want you to understand what all of this means. The energy of an emitted photon, who that gentleman on the bottom left is, what those two models on the right look like. First off, this might seem a little overwhelming, but let's take it one piece at a time. How do we get here? Well, here are the three general models you'll typically see in a chemistry classroom setting. However, the model on the way right is what the real-life models look like, and the model on the way left is what was believed to be correct in the early 1900s. Here are the scientists associated with their models. On the way left, you have Rutherford, who came up with his model of the protons, neutrons, and electrons. Then you have Bohr, which then we'll see in here in a little bit of how he did his mathematical relationships. And on the way right, you have two gentlemen which we have not yet quite talked about in the classroom, and we're not going to worry about just yet. However, these scientists did build off one another in coming up with their models. Like I said, we don't really use Rutherford's model anymore. Niels Bohr model will be used for mathematical relationships. Most modern day chemistry uses the real-life models. However, we're going to be focusing on Niels Bohr and his mathematical relationships today. Well, who is Niels Bohr? Lived, died, and studied in Copenhagen, Denmark. Studied at Copenhagen University, born in 1885, died in 1962. His field is theoretical nuclear physics, and he won the Nobel Peace Prize for the model, for his services in the investigation of the structure of atoms and the radiation emanating from them. Well, this is what Bohr's model looks like. Like I said, it's going to be a complicated math behind it, and however, let's break that down a little bit. Here's a common formula for using only on the hydrogen atom. When you get into the other atoms, it gets a little bit more difficult as far as the math manipulation goes. We will never get there in this course, and that's something you'll only see in a college classroom setting. Well, let's break this down a little bit. You have Rydberg's constant, which is a constant, like I said, in classroom settings. A constant is a constant is a constant. You have your starting orbital level, your final orbital level, Planck's constant, like I said, a constant is a constant is a constant. And I will give you all those for all finals and tests and exams and things like that. Then you have frequency and the energy. Well, we're going to be working specifically with the energy of an electron movement. An electron will either absorb energy and go to the orbital level above it, release energy and go to the orbital level below it, and from that we're able to calculate which orbital we are going to by emission or absorption of energy. So, let's continue on with this lesson by thinking of how you are adding electrons and how that would affect energy required for absorption or energy released in emission. Reminding yourself that Bohr's model is only used for mathematical purposes. We'll get the real 3D models later using Vesper. Finally, try calculating some energy requirements on your own. Do you understand what this means now? If so, continue on with the lesson. If not, repeat the video.